So in this lesson, we're going to represent unit rate. This is a new thing in different forms. So let's read the first situation. Annabelle travels 3 miles per hour. This is our unit rate. Unit rate. So right away, we can go to this box right here and go ahead and write it. So our unit rate, we're talking about miles every 1 hour. So 3, let me make that blue. 3 miles every 1 hour. 3 miles every 1 hour. So ultimately, like what we're talking about, what it asks about, how far will she travel in 20 hours, it's asking about how far she traveled. We're asking about the distance. We're asking about the miles. So the miles will go and will be the will be the dependent variable. The miles, the number of miles, will be the dependent variable. And what will determine that is the number of hours she traveled. You could also put distance and time, like D and T, but I like to put the units, the first letter of the units, as my variable. The first thing is my table. We are talking about the number of hours. It doesn't tell us what to count by, so I'm just going to go 0, 1, 2, 3. And that will affect the number of miles traveled. So, but we all know if you don't travel like at all for no amount of time, you would get 0 miles, right? But after 1 hour, how far should Annabelle have traveled? That's easy. That's 3, because it's 3 miles every 1 hour. So another hour, she would travel 3 more, and she would be at 6. Another hour, she'll have traveled 9. One other way of doing this is just multiplying 3 times the number of hours, times the number of hours, times the number of hours. And even with the 0 times 3 isn't 1, isn't 3, it's 0. 0 times anything would give us 0, right? So let's look at our graph. So we're talking about the number of miles after the number, depending on the number of hours. So if Annabelle travels 0 hours, she will have gone 0 miles. If she traveled for 1 hour, she will have gone 3 miles. If she traveled 2 hours, she will have gone 6, and then 9. And let's do my best to not mess this up too bad. Okay, that's started off okay. Let's start off fairly promising. Okay, cool. There was one right there. So let's go ahead and write 2 equations. So if we take the number of hours and multiply it by 3, we will get the number of miles. But that's not the way you're going to see it most of the time. Most of the time, you're going to see it like this. The miles equals 3 times the hours, or 3h. Let's not forget that it asks us for a prediction. It says, how far will she travel in 20 hours? So let's go ahead and try that. So 20 hours times 3 should give, should give us the number of miles. So let me back up. Let's write the equation first. H times 3 should give me m. Let's replace the h with 20 miles. And 20 times 3 is 60. So 60 equals the number of miles. So you could also just put miles equal 60. If you feel more comfortable using this one right here, miles equals 3h, then you can do that one too. We'll do that in the next problem, the next situation. Either equation will work as long as you show the work for it, okay? So our prediction. So if she travels 20 hours, then she will have gone 60 miles. All right, let's do the next situation. So the water level rises 0.5 centimeters, half a centimeter, every ice cube you put in the glass. So we're talking about water level. Centimeters would be the water level. And that's going to depend on the number of ice cubes. Number of ice cubes. How far will the water level rise, or how much will the water level rise after 13.5 cubes have been added? So ultimately our unit rate right here is 0.5 or half, 0.5 centimeters per ice cube. One ice cube. So ultimately we're concerned with the rise in water level. So I'm going to use W for water level. Oops. And we measure that in centimeters. That will depend on the number of ice cubes. So we'll just put ice cubes. So number of ice cubes, which doesn't tell us what to count by or anything. So 0, 1, 2, 3. And that will affect the water level. So 0 ice cubes, the water level will rise. Like if you don't put any ice cubes in, the water level doesn't change. It's stuck at 0. If you put 1 ice cube in, it will rise half a centimeter. If you put 2, it will be 1 centimeter. If you put 3, it will be 1.5 centimeters. Now, how could you get this if you weren't comfortable counting by this, by half a centimeter? You could always just multiply by by 0.5, 0.5. So let's go ahead and graph. This is the water level, and this is how many ice cubes. And if we do this, it starts at 0, 0, 0 ice cubes, 0 change in water level. 1 ice cube, which is here, half O is going to be a squeeze right there. 2 ice cubes would be 1 centimeter. And 3 would be 1.5. So that's kind of squished, but they're kind of going like that, right? All right, let's make 2 equations. So if we take the ice cubes and we multiply by, I don't have to change the color, and we multiply by, I still will. Multiply by 0.5, then we will get the change in water level. We could also just say that the change in water level is 0.5 for every ice cube. Now let's go ahead and use that to make a prediction. Now last time I used the first equation, I'm going to use this one because most people prefer this one actually when they get used to it. So the water level is 0 change in water level is 0.5 for every ice cube. So the water level is going to be 0.5 times how many ice cubes? They gave us 13.5 ice cubes. And so the change in water level will be 6 and 7/500. You multiply there, so I already know the answer. 6 and 7/500 centimeters. Don't forget your unit of measurement. Like I said, if you prefer to use the first equation, you can do it like that. If you prefer to use the second one, do it like this. So, and I know I didn't do it in the last one, but if you want, well, what I want you to do here is put that 13.5 would end up being at, making it rise 6.75 centimeters. So, oh, that's my explanation. So if you add 13.5 ice cubes, then the water, the H2O, will rise. There we go. Will rise 6.75 centimeters. And that is it. I'm just going to add the answer over here for the people who are really looking at the notes. So this was 20 hours is 60 miles. And cool. So that's it. Thank you.